மேம் எதுவும் பேச வைக்கல, எதுவுமே கேட்கல மேம்.
Ma'am, your voice is not audible.
யாருமே கேட்க மாட்டேன்றாங்க, எல்லாரும் அமைதியா பாருங்க, எல்லாரும் படி கேட்கும்போது தெரியுது. அவங்க பாட்டுல படம் ஓடிட்டே இருக்காங்க.
மேம் உங்க வாய்ஸ் கேட்கல மேம். மேடம்
பேசுறது எதுவுமே கேட்கல மேம். கைண்ட்லி உங்க ஸ்கிரீனை ஜூம் பண்ணி எடுங்க மேம்.
மேம் நாங்க பேசுறதா கேக்குதா உங்களுக்கு?
டாக்குமெண்ட் தான் மெசேஜ்லயும் போடுறாரு. Ma'am, the phone number is there. Ma'am, the voice கேட்கல.
Now it's audible. Now it's audible.
Yes, ma'am.
Mic is mute. I mean, now my mic.
We are not able to hear you. Okay. Hey guys, can you hear ma'am voice?
கைஸ் என்னாச்சு ஸ்கிரீனே டிஸ்ப்ளே ஆகல.
The madam screen but we are not able to hear my voice. கேக்குதா நான் பேசுறது?
கிளியரா இல்ல. எதுவும் சொல்றீங்க பட் கிளியரா இல்ல.
இல்ல மேடமோட வாய்ஸ் இன்னும் கேட்கல யாருக்குமே.
ஓகே ஓகே தேங்க் யூ.
Basic notations. The first one is called as class, which is represented by a rectangle, which has three different sections. One is called as the top section containing what name of the class, this section containing the attributes of the class, and the bottom section containing the operation of the class. So the visibility of the attributes and the operation can be represented in the following way. We know the accessibility about the members of the class, which are called as public, private, and protected. The public means what? You can able to access these members of the class outside the world. That is denoted inside this class is what? A plus symbol. Private means you cannot able to access outside the class, but we can able to access the private members through the method of the class. That represented in the class diagram as what? A minus. We are leading with the minus symbol. Any property or operation that lead with the minus symbol, then that called as what? Private. And protected, we know that, which is similar to private, but only one relaxation is being out now. The class is immediately emitted by another class, but in particular class, all these protected numbers are what? Have this shared. So that will be used in the symbol is called as water ash. So properties under a protection is water. It's like a private only, but water we can have the privilege to access the immediately emitted class. So what is abstract class? As a class name written in italics. That's the only water difference between a normal class with an abstract class. For example, let us consider a circle class introduced earlier. We already discussed about the circle class, which contains radius and the x coordinate and the y coordinate, and two different methods. One is called as finding area, and one is called as what? Finding surfaces. So we are going to draw the class diagram for that example. Now see the example of this. So circle is the name of the class, therefore it is top of the diagram, rectangle region. The next middle is we are going to define the attributes. So we'll have the three type of attributes, three different attributes: x coordinate, y coordinate, radius. So here is minus symbol leaded by x and y coordinate. Therefore they are called as what? Private attributes. And the hash symbol leading by the radius, therefore it is called as a protected attribute. And third is the operation of the circle. What are the operations we are going to perform here? Find area, find the circumference, and scaling the coordinators. So all these leading with plus symbol, therefore they are called as what? Public scope. So we can access through the object these three methods only outside the class because all are defined under the public mode. So this is a diagram view about a circle class. So which is clearly given. Top is name of the class, middle is attributes of the class, final bottom is called as operation of the class. The next is object. So what is an object? How it is represented? So an object is represented as a rectangle with the two sections. The top section contains the name of the object with the name of the class or package of which it is an instance of. The name takes the following forms: object name, class name, or object name, class like this way. So object name, class name, or class name, scope resolution, package name, class name in case of anonymous objects. The bottom section represents the values of the attributes. It takes the form on the attribute name equal to values. Normal assignments. Sometimes objects are represented using a round rectangle also. So we can also define an object both rectangle or round rectangle manner. Now, in the example, same class in the circular, we are creating an object C1. We are assuming that the center of C1 is 2, 3 and the radius of C1 is 5. So the figure is shows that what? C1 colon, which represents what? An object of the class circle. It's the top of your object creation. So in the bottom, what we are having, the value which is assigned for the x and y coordinates and what radius. So x coordinate value is given here as 2 and y coordinate value given here as 3 and the radius is equal to what? 5. So object name is in around the rectangle region is given here. Okay, both are same, both are denoting only what? Object diagram. So component is a physical and replaceable part of the system that conforms to and provides the realize of a set of interfaces. It represents the physical packaging of elements like classes and interfaces. So in the UML diagram, the component is represented by a rectangle with the tabs as shown in the figure. So the component is defined here. Rectangle part which are interconnected tab given here. An interface is a collection of methods of a class or component. It specifies a set of services that may be provided by the class or component. What is the notation for an interface? So an interface is drawn as a circle together with its name. An interface is almost always attached to the class or component that realizes it. The following figure which gives what a diagram view about an interface. So here is a circle which shows us an interface. Under the circle that denotes the interface name. So in between part of the diagram it may be a class or a component. In the example, they are linked to a component. Therefore, first circle denoting interface 1 and at the end of the circle is denoting interface 2. These two interfaces which are connected with the component 1. So what is a package here? It's an organized group of elements. It may contain structural things like classes, components, and other packages in it. So notation which are used for the packages is generally drawn with its name. Additional details about the contents of the package is an example is given. The customer. The customer is an information that is customer package. So for top of the package which will have the customer under its properties will have the methods what? Personal details, account details, loan details. So it's going to show us a what? Diagram of your package. It's a simple package, you want to choose a customer, we are not entering anything. The next is we are going to assign the operation for the packages. It will be shows along with the public properties. When it's laid with the plus symbol, we can say it's what to public properties. The next is relationship of the UMLs. The notation for the different types of relationships are as follows. If it is a dotted arrow, it is called as a dependency. If it is a solid line, it is called as a association. If it is a solid arrow, direct association. If it is there is a triangle arrow which is called as inheritance, again dotted with the arrow symbol realization, and solid with the decision making symbol, diamond symbol, which is called as the aggregation. The elements in a relationship place specific rules in the relationship. A role name signifies the behavior of an element participating in a certain context. So the next again a figure which we are going to get the relationship. What now see. So in the relationship we will have the symbol. Based on symbol we can say 1 to 1 or many to many, something like that. So the one alongside department and star alongside employee depicts the cardinality ratio is 1 to many, and second figure portrays the relationship university, that is aggregation relationship of a university is the whole of many departments. So now employee worker, employee, many employee works under a single department. So employee, then a star symbol denoting many. Department, one denoting one department. Many employee works in a single department. So here is one. As in university pattern, one university have many departments. That's what's given here. One university have many departments. Here is many employee work under a single department. One university have many departments. The next diagram view. What is structural diagram in the human part? Now this is a simple example. It shows that how a human diagram is different for a class. In which a class is taken, a bank has many branches. Zone one branch is designated as a zonal head office that supervises the other branches in that zone. Each branch can have multiple accounts and loans. An account may be either a savings account or what, current account. The customer may open both the savings account and the current account. The customer must not have more than one savings account or current account. The customer may also procure loans from the bank. Is the following correspond? What are the conditions given over there? Here, class diagram will be written for this. The first class diagram shows that the bank, second is branch, third is account, fourth is loan, whether it's a savings account or current account, it will be activated by the customer. Okay, that's another class. So we'll have 7 classes here. So first, the bank class. The attributes are name, code. The operations are add branch, remove branch, get all branches. Under this branch, because one bank have the many branches. So that the symbol is given like the relationship. Now the branch have branch code 60. It might have one zonal head office, have many branches. So operation within this board, add account, remove account, get account, add loan, remove loan, get loan. Again the loan class will have the attributes like what, loan number, amount, type. So many loan will be comes under a single branch. Add customer, prepayment, gets EMI. For the account, we'll have what? Account number, balance. We're going to do what? Debit amount, credit amount, get balance. It might be what? 0 to many part, but it comes under a single branch. And these two denoting the part of what? Savings account and the current account. Again, one customer have many, 0 to 1 customer having the savings. Again, 0 to 1 customer having the current account. So one customer have 0 or 1 savings account or 0 or 1 current account. So what are the properties under this? We'll have what? Both savings and current term, minimum balance, date of opening. Add customer, remove customer. But in the current account, interest rate, date of opening. Next is customer, which contain the following attribute only. There's no operations. Customer ID, name, address, phone number. Classes in the system, what? Bank, branch account, savings account, current account, loan, and customer. Relationships, what is given here? A bank has a number of branches. The composition is 1 to many. A branch with rule, zonal head office supervises other branches. Which is another association. So 1 to many. A branch has a number of accounts, which is aggregation 1 to many. From the class account, two classes have inherited, namely savings account and the current account. So a customer can have one current account association with what? 1 to 1. A customer can have one savings account, again association with what? 1 to 1. A branch has a number of loans, therefore it is an aggregation 1 to many. A customer can take many loans, therefore association with what? 1 to many. Now the same thing we are going to draw the diagram for the objects. So the diagram shows the instance of the things in the class diagram. It's a static part of an interaction diagram. Now this is an example which is taken for the bank system. So an object B1 is created, B2 is created for the bank. B1 is created for the bank and BR2 is for the branch, BR1 is for the another branch. So in the bank object is containing what? Name and code. So bank of ABC, BO ABC is the code for this. And the branch 2 will have the properties what? The attributes like branch code and city. Similarly for the same BR1 is also having the branch code and city. And branch zonal one, only one zonal office for the branch. Therefore, it's directly from the bank. So branch code again, city will take. So three different objects for the branches, but only one is for the zonal branch. It is limited from the branch ones. So zonal head office, zonal head office. That to be taken the properties from the BR2 and BR1 taken it from the zonal office 1. So component diagrams shows the organization and the dependencies among the group of components. Which will have the diagram like what? The components, interfaces, relationships, packages, and the subsystems. So it's optional. The component diagrams are used for what? Constructing systems through forward and reverse engineering, modeling configuration management of source code, files while developing a system using an object-oriented programming language.
Right.
And the representing schemas in modeling databases, modeling behaviors of dynamic systems. So the following thing is a component diagram to model a system source code that is developed using the C++. It shows 4 source code files, namely myheader.x, otherheader.x, priority, and other. 2 versions of myheader are shown, placing from the recent version to its ancestor. The file priority has compilation dependency on other. The file other has compilation dependency on other header. Now see this component diagram for the class. So myheader.x is a version of 2.0 and myheader.x is a version of 2.2. So priority.cpp and other header other.cpp. This is called as a component diagram of the system. Next is deployment diagram. So this diagram emphasizes on the configuration of runtime processing nodes and other components that live on them. They are commonly comprised of what? Nodes and dependency are associated. So what is the use of component diagrams are used for what? Model devices in embedded systems that typically comprise of what? Software intensive collection of hardware, which represents the what topologies of the client or server systems. It's fully what distributed system. This is an example for what The following figure shows the topology of computer system that follows client and the server architecture. This figure illustrates a node stereotyped as server that comprises of processes. The figure indicates that 4 or more servers are deployed at the system, connected to the server or the client nodes, where each node represents a terminal device, such as workstation, laptop, scanner, or printer. The nodes are represented using icons that clearly depict the real world equivalent. This is what a deployment diagram. So one server that will be connected with the more than one client. So the client may be a system, a laptop, or printer, something like that. So this is what an example diagram for your deployment diagram. And OIDUML behavioral diagrams, which are visualize, specify, constructs, and document the dynamic aspects of the system. The behavioral diagrams are categorized as follows: use case diagrams, interaction diagrams, state diagram, chart diagrams, and activity diagrams. So what is a use case model? So use case describes the sequence of actions the system performs yielding visible results. It shows the interaction of things outside the system with the system itself. The use cases may be applied to what? The whole system as well as a part of the system. In the use case, we'll have an actor which represents the role that the user of the use cases play. An actor may be a person, he may be a student, a customer, something like that. A device may be a workstation, or another system may be a bank or institution. So the following figure shows the notations of an actor named student and the use case called generated performance report. Generate performance report. So actor like an object which is given here. This is diagram view about an actor. The name of the actor is student, and the use case is generate performance report. That's it. We are going to perform a generate a performance result of the student. So in the use case diagram, which comprises into use cases, actors, relationships like the dependency, generalization, and the association. These diagrams are used for what? Context of the system by enclosing all the activities of the system within a rectangle and focusing on the actors outside the system by interacting with it. To model the requirements of the system from the outside point of view. Now is an example which is going to show about here how a use case diagram is created. So automated trading house system. That is our use case diagram here. We are seeing the following features of the system. One is what? Trading house has transaction with two types of customers, individual customers and corporate customers. Once a customer places an order, it is processed by the sales department and the customer is given the bill. The system allows the manager to manage customer accounts and answer any queries posted by the customer. So this is the only task about water automated trading house. Now see the characters here. Individual customer, corporate customer. So from the customer, we'll have the two classifications of the customer. One is the individual customer, and one is the corporate customer. So yeah, remember the right hand side part of the actors are sales department manager. So what are the tasks which are performed by the automated trading house systems? Accept orders, process order and generate bills, manage customer accounts, handle queries. So these are the process comes under this. Now see who are all going to play the roles. Sales department going to what? Accept orders, process order and the customer generate bills. That is a department work sales department process. The manager will do what? Manage the customer accounts and what? And the queries. So all these four processes can able to access by a customer. Whether he is a corporate customer or individual customer, they can able to access all these four processes. The next is what? The interaction diagram. The next is interaction diagram. which depicts interaction of objects and the relationship. Also include messages passed between them. There are two types of interaction diagrams. One is called sequence diagrams, and another one is called what? Collaboration diagrams. So the diagrams are used for modeling, control flow by time ordering using sequence diagrams, control flow of organization using collaboration. The control flow of ordering using sequencer, time ordering in the sequence, and organizations using collaboration. So what do you mean by a sequence diagram? Which are interaction diagrams that illustrates the ordering of messages according to time. So notations, the diagrams are in the form of two-dimensional charts. The objects that initiate the interaction are placed on the x-axis. The messages that these objects send and receive are placed along the y-axis in the order of increasing time from top to bottom. This example shows that automated trading house system. The object is created for the customer, object is created for the salesperson, and customer record object is created, stock object is created, manager object is created. Now these are the objects which are placed under about X ordinate. What is given in the Y ordinate? Sending the message or receiving the message along with the Y ordinate. Then the customer they are going to place order. Invalid customer means again they will going to rejected order. There is no stock means apology message from the salesperson if confirm order. So these are the four messages which will be sent and received. Actually one message only sent by the customer. What is that? Place order. Now the salesperson object responds to replay the order, status about the order. If they are invalid customer, they are going to reject the order. If there is no stock in the sales, we will going to apology message they will send to the customer. If order is confirmed, they will send the confirm order. So this is the message from the customer with the sales. Now there is a message from the apart from this from the customer. They are in their information will be sent to the manager. Manager will what? Any query that will be sent by the customer that will be sent to the manager. Manager will respond to reply the query. So answer the query part. See these are the two sending information, four receiving information by the customer object. Now salesperson going to what? Customer record. He going to find whether the customer existing in the customer record. If it's fine, if it's existing in the customer record, he's going to check whether the stock is available or not from the stock object, finding stock. And if finding, not only finding, we can the salesperson may able to update it. So what is other messages? One thing that just is checking whether the customer is existing in the customer record. If it is there, he's going to do all other process. Before going to place the order, he's going to check whether the stock is available or not. If it is not available, he's going to update and do something else. This is called as what a sequence diagram for the automated trading house. Now the collaboration diagrams are interaction diagrams that illustrate the structure of the objects that send and receive messages. So notations are these diagrams, the objects that participate in the interaction are shown using HSS. So links that connect the objects are used to send and receive messages. The message is shown as here labeled arrow. This is again the example for the automated trading house system, which is denoting the collaboration diagram. So objects which we have are similar to what customer object, sales object, customer record, stock, and what manager. So under this first state, placing order. Customer placing order that going to be your salesperson. He going to check whether is a valid customer, invalid customer. Check finding customer record. If he is exists in the customer record, he going to do check find stock. If stock exists, if stock is there, he going to what? Confirmation order. If stock is not, he are going to futurely updating the stock. See if the customer is not in the record, therefore we are going to say in rejecting the order. If there is no stock, we are going to say as what apology message to the customer. So once stock is there, we are going to confirm the order. Again, this message sent to the customer. So any query is raised from the customer to the manager, he is going to reply part. It's a 9 stage about the what query message error part. This is called as what collaboration diagram of a system. The next is state charters diagram. It shows a state mission that depicts the control flow of an object from one state to the another state. The state mission portrays the sequences of states which an object undergoes due to events and their responses to events. State chart diagram comprises of what? States, transitions, events, actions. States is a simple or composite transition between the states, events causing transactions, action due to the events. The states are for again what modeling of the which are a reactive nature. Again, the state diagram for your automated trading house. The initial state we are going to start state of the transition diagram. So we are receiving an order and unprocessed. So receiving an order, it's unprocessed good order and whether we are going to accept or reject. So unprocessed order will be going to the good order part. They are going to accept. Then it is processed.
Ma'am, excuse me, ma'am. Ma'am, kindly speak louder, ma'am. We can't hear your voice properly, ma'am.
Order means if it is a good order means we are going to accept today. Quality order means what rejected again going to water final state. So first,
Ma'am, excuse me, ma'am. Can you able to hear my voice, ma'am?
Unprocessed whether it's a good order or a quality order. So this is a diagram shows.
Ma'am, kindly speak louder, ma'am.
State about the transition diagram. If a process order means delivered or if it is rejected again. The next is
கேட்க மாட்டான் போது
so it depicts the flow of activities which are ongoing non-atomic operations in a state machine. So activities result in actions which are atomic operations. So diagram comprises of activity states and the action states, transitions, and finally objects, which are used for modeling of flows as viewed by actors interacting with the system. Details of operations are computations using flowcharts. Now this is called as an activity diagram of the automated trading system. We have the activity like what the customer, salesperson, stock, then work. If the customer pays order, the salesperson processes the order. Stock is get delivered or is not updated. Then bill is generated. So we are receiving order and pay bill. Then close order. And the only thing is what? We are not doing anything, something which is not given yet. It's an activity only what a customer going to place an order, the salesperson going to process the order and then generating the bill, they will pay the bill. All that's it. It's the diagram for the activity. So we will continue with the small break. We'll meet again 11:30.
ஏமா இங்க வந்து ஏன் வச்சா இங்க போய் போன ஏன்
The next topic is object-oriented design part. The conceptual model is developed further into object-oriented model using what? Object-oriented design part. So in the OID technology is a technology-dependent concept which analyze model or map down to implementing classes, constraints are identified and the interfaces are designed, resulting in a model for the solution domain. In a nutshell, a detailed description is constructed specifying how the system is built on concrete technologies. So what are the stages of an OOD? OOD. Stages of the OOD. The first stage is called as the definition of the context of the system. The second stage is called as the designing system architecture. Third stage is called as identifying of the objects in the system. Fourth is called as the construction of design models. Fifth is called as the specification of object interfaces. These are the 5 stages which are used for what? Object-oriented design. The first is system design, which involves defining the context of a system, followed by designing the architecture of the system. So in the context, the system has a static and dynamic part. Static context of the system is designed using a simple block diagram of the whole system, which is expanded into a hierarchy of subsystems. The subsystem model is represented by UML packages. The dynamic context describes how the system interacts with its environment. It's modeled using use case diagrams. System architecture is designed on the basis of the context of the system in accordance with the principles of architectural design as well as domain knowledge. Typically, a system is partitioned into layers and each layer is decomposed to form the subsystem. What is decomposition? This means dividing a large complex system into a hierarchy of smaller components with lesser complexities on the principles of divide and conquer. So you know that the theory of divide and conquer. So whatever the complex problem is there, that will be first divided into small problems. We are finding the solution for the small problems, then the solution which are made for the altogether. So that's going to produce the solution for the complex problems. This concept is called as what? Divide and conquer in your design of algorithm. So that principle is followed in the decomposition. Each major component of the system is called a subsystem. So in the design of algorithm, they are called as subproblems. So here is subsystem. So in the object-oriented decomposition, identifies individual autonomous objects in a system and the communication among these objects. What are the main advantages which are on the decomposition? The individual components are of lesser complexity and so more understandable and manageable. It enables division of workforce having specialized skills, which allows subsystems to be replaced or modified without affecting other subsystems. So identifying the concurrency, how to identify the concurrency, which allows more than one object to receive events at the same time and more than one activity to be executed simultaneously. The concurrency is identified and represented in the dynamic model. To enable concurrency, each concurrent element is designed a separate thread of control. If the concurrency is at object level, Then two concurrent objects are assigned two different threads of control. So if two operations of a single object are concurrent in nature, then that object is split among different. The concurrency is associated with the problems of data integrity, deadlock, and starvation. So a clear strategy needs to be made whenever concurrency is required. So design, the concurrency requires to be identified at the design stage itself and cannot be left for implementation stage. So identifying the patterns, how to identify the pattern. When designing applications, the commonly accepted solutions are adopted for some categories of problems. So these are the patterns of design. The pattern can be defined as a documented set of building blocks that can be used in certain types of application development problems. So what are the commonly used design patterns? Facade pattern, model view separation pattern, observer pattern, model view controller pattern, publish subscribe pattern, and proxy pattern. The controlling events, how to control the events. During system design, the events that may occur in the objects of the system need to be identified and appropriately dealt with. An event is a specification of a specific occurrence that has a location in time and space. There are four types of event that can be modeled, namely signal event, call event, time event, and the change event. So what is signal event? A named object thrown by one object and called by another object. It's called as what a signal event. What do you mean by call event? A synchronous event representing dispatch of an operation. The time event is representing passage of time. And this is called as change in state. Change event is occurs only change in state part. Handling boundary conditions. So what are the conditions that we are going to handle? Startup of the system, that is the transition of the system from non-initialized state to steady state. And the termination of the system, that is the closing of all running threads, cleaning up of resources and the message to be sent. The initial configuration of the system and the configuration of system when needed. Foreseeing failures or desired termination of the system. The boundary conditions are modeled using boundary use of cases. The boundary use cases. The object design. The hierarchy of subsystem has been developed. The objects in the system are identified and their details are defined. So here the design details out the strategy chosen during the system design. The emphasis is shift from application domain concepts towards the concepts. Concepts identified during analysis are extended for implementation with an aim to minimize execution time, memory consumption, and overall cost. So when you're going to minimize the consumption of the space, that's the time that is going to increase the project cost. So in the design includes the following phases. So what are the phases of the object design? Object identification, object representation or construction of design model, classification of operations, algorithm design, design of relationships, implementation of control for external interactions, package classes and association into modules. So what is the phase of object identification? The first step of object design is object identification, which are identified in the object-oriented analysis phases and grouped into classes and defined so that they are suitable for actual implementation. So what are the functions of this stage? Identifying and refining the classes in each subsystem or package. Defining the links and the associations between the classes. Designing the hierarchical association among the classes, that is the generalization and association and the inheritance. Designing aggregations. Object representation means classes are identified, they need to be represented using object modeling techniques. In this stage, it essentially involves constructing UML diagrams. There are two types of design models that need to be produced. One is called static model, another one is called the dynamic model. Describe the static structure of a system using class diagram and object diagrams. The dynamic, which describes the dynamic structure of a system and show the interaction between the classes using interaction diagrams, state chart diagrams. The classification of operations. Performed an object are defined by combining the three models developed in the OOE phase, namely object model, dynamic model, and the functional model. An operation specifies what is to be done and not how it should be done. These are tasks performed by the regarding the operations. One is called as state transition diagram of each object in the system is developed. Operations are defined for the events received by the objects. Cases in which one event triggers other events in same or different objects are identified. The sub-operations within the actions are identified. The main actions are expanded to the data flow diagrams. What is algorithm design? The operation the objects are defined using algorithms. We know algorithm is a step-wise process by using the code. So an algorithm is a step-wise procedure that solves the problem laid down in an operation. The algorithm focus on how it is to be done. There may be more than one algorithm corresponding to a given operation. Once the alternative algorithm are identified, the optimal algorithm is selected for the given problem. So what is they are going to try to tell you? A particular task will have the more than one algorithm. So first you get creating an algorithm in a basic manner. After the refinement of the algorithm, we'll get an advanced level. I mean, what do you mean with advanced level of the algorithm is we are trying to minimize the time of the execution of the algorithm as well as minimize the space of the algorithm. So what is space that's going to occupy the while during the execution part. So these two will be concentrated on the procedure created part. So once on the procedure created, we are going to try to minimize both the number of lines, the number of variables, how they are used for the previous stage, that will be minimized to the next stage. So these two are called as what managing our operation performance. It is called as alternative algorithms. So already an algorithm is there for a task. We are going to create an advanced level that is going to minimize and minimize both the time and the space complexity. So the metrics for choosing an optimal algorithm are computational complexity, flexibility, understandability. So what do you mean by computational complexity? The efficiency of an algorithm in terms of computation, time, and memory requirements. That is called as space. The flexibility, which determines whether the chosen algorithm can be implemented suitably without loss of appropriateness in various environments. So understandability is nothing but it determines whether the chosen algorithm is easy to understand and include. And the design of the relationship, the next strategy to implement the relationship needs to be charted out during the object design phase. The main relationships that are addressed comprise of associations, aggregations, and the inheritance. So what are the associations that are allowed for the designing your algorithm? Identify whether an association is unidirectional, unidirectional or bidirectional. Analyze the path of association and update them if necessary. Implement the association as a distinct object in case of many-to-many relationships, or as a link to other objects in case of one-to-one or one-to-many. So regarding interfaces, the designer should do the following: adjust the classes and their associations, identify abstract classes, make provisions so that behaviors such as we know about what is an abstract class. It is similar to an interface. In an abstract class, it's going to prevent the inheritance. You cannot extend this abstract class to another class. So all the methods, you only meant for the inheritance part. So all the properties which are what final and the methods only declare like interface. Wherever it is going to only act as a base class to all other classes, we cannot be able to create an instance. It is like an interface. That is called a abstract class in your C++ as well as in your Java part. The implementation of control. The object designer may incorporate refinements in the strategy of the state chart model. In system design, a basic strategy for realizing the dynamic model is made. During object design, this strategy is softly embellished for appropriate implementation. So what are the implementation approaches in the dynamic model? Represent state as a location within a program. State mission engine, controllers to concurrent tasks. These are things comes under your approaches of implementation dynamic model. So what about these represent state as a location within a program? This is the traditional procedure-driven approach whereby the location of the control defines the program state. A finite state mission can be implemented as a program. A transition forms an input statement. The main control part forms the sequence of instructions. The branches form the conditions, and the backward part form the loops or iterations. These comes under the represents state as a location within a program. State machine engine. This approach directly represents the state machine through a state machine engine class. This class executes state machine through a set of transitions and actions provided by the application. Controllers concurrent task. In this approach, an object is implemented the task in the programming language or the operating system. Here, an event is implemented as an inter-task order. It preserves inherent concurrency of real objects. The packaging classes. A large project, meticulous partitioning of an implementation into modules are packaging important. During object design, classes and objects are grouped into packages to enable multiple groups to work cooperatively on a project. The different aspects of packages: hiding internal information from outside view, coherence of elements, construction of physical models. So, what is hiding internal information from outside? It is called as an encapsulation in concept, which allows what a black box. The black box water allows a class to be viewed as a black box and permits class implementation to change without requiring any client of the class to modify code. The governance of elements, an element which is just a class, an operation, or a model is the coherent. It is organized on a consistent plan, and all its parts are intrinsically related so that they serve a common goal. The construction of physical modules. The following guidelines are used for constructing physical modules. Classes in a module should represent similar things or components in the same component. So closely connected classes should be in the same module. Unconnected or weakly connected classes should be placed in separate modules. Modules should have good cohesion, high cooperation among its components. The module should have low coupling with the other modules, that is, interaction or interdependence between modules should be water in it. The design optimization. The analysis model captures the logical information about the system, while the design model adds details to support efficient information access. Before a design is implemented, it should be optimized as to make the implementation more efficient. The aim of optimization is to minimize the cost in terms of time, space, and other elements. So the design optimization should not be excess. As the ease of implementation, maintainability, and extensibility are also important concepts. And it is seen that a perfectly optimized design is more efficient, but less readable and reusable. So the user must strike a balance between the two. The various things that may be done for design optimization: to add redundant associations, omit non-usable associations, optimization of algorithms, saves derived attributes to avoid the recomputation of complex expressions. The addition of redundant associations. So it is going to do what during design optimization? Check if deriving new associations can reduce access cost. So these redundant associations may not be add any information. They may increase the efficiency of the overall model. Formation of non-usable associations. Presence of too many associations may render as a system indecipherable and hence reduce the overall efficiency of the system. So during optimization, all non-usable associations are removed. So optimization algorithms. In an object-oriented system, optimization of data structure and algorithms are done in a collaborative manner. So once the class design is in place, the operation and the algorithms need to be optimized. The optimization of algorithm is obtained by rearrangement of the order of computational tasks, reversal of execution order of loops from that laid down in the functional model, removal of dead parts within the algorithm. So saving and storing of derived attributes. Those attributes are, whose values are computed as a function of other attributes. They are called as base attributes. So recomputation of the values of derived attributes every time they are needed in a time-consuming procedure. So avoid this, The values can be computed and stored in their computed forms. This may pose update anomalies, that is, the change in the values of base attributes with no corresponding change in the values of the derived attributes. So, these following steps are taken. With each update of the base attribute value, the derived attribute is also recomputed. All the derived attributes are recomputed and updated periodically in Able rather than after each update. So what is design documentation? An essential part of any software development process that records the procedure of making the software. The design decisions need to be documented for any non-trivial software system or transmitting the design or to others. The usage area through a secondary product, a good documentation is indispensable, particularly in the following areas. In designing software that is being developed by a number of developers. In iterative software development strategies, developing subsequent versions of the software project, for evaluating a software, for finding conditions and the areas of testing, for maintenance of the software. The contents are the beneficial document should essentially include the following contents: high-level system architecture, key abstractions and the mechanisms, scenarios that illustrate the behavior of the main aspects. The process diagrams and the model diagrams are used for the high-level system architecture. Class diagrams and object diagrams are used for the key abstractions and the mechanisms. And the behavioral diagrams is used for scenarios that illustrate the behavior of the main. The features of the good documentations are concise and at the same time unambiguous, consistent and complete. And traceable to the system's requirement specifications, well structured, diagrammatic instead of descriptive. These are things comes under this.
Ma'am, your voice is not audible. Yeah, okay.